Namaste and welcome to Code Divinity. I am your coding friend Om with another easy level problem. Find the highest altitude. So in this problem, there is a biker and this biker is going on a road trip. This road trip will be filled with ups and downs, just like the path we are following for our competitive programming. And we have to find the highest altitude that the biker has reached during his journey. In this problem, we will be provided an array of integers, gain, and this gain will be containing the difference of altitude between two adjacent points. So this is our gain input, and it is mentioned that the biker will start at level 0. Let's account our given gain input. From the initial point 0, the biker will go -5 levels deep. Then it will rise by 1 point. Then it will rise by 5 points. Then the level remains same, so the altitude difference is 0. Then it will rise by 7. So our task is to find the point of highest altitude during this entire journey. So in order to find the highest altitude, I'll share an easy algorithm with you. First, we will declare two integers, max altitude and current altitude. Initially, the maximum is 0 because biker is at 0 level, and current altitude is also 0 initially. So we will set both of them as 0. We will start a for loop from I equals to 0 and it will go up to size of gain input. Within this for loop, we will add the current altitude with the current element of gain. So here we are performing the cumulation of all the altitudes. And as soon as we calculate the current altitude, we will check if the max altitude has become smaller than our current altitude. So when our current altitude is pointing at a higher position, that means we have found a new max altitude during our journey. So we will update max altitude to our current altitude, and we will keep updating it during our entire journey, and finally when the loop will terminate, we will return max altitude as our answer. Let's theoretically check our algorithm on our previous example. So our example was, and our variables max altitude and current altitude are initially 0. So firstly, when the loop will begin, I will be 0 and gain of I is -5. So our current altitude will become -5. We will check if the current altitude is becoming greater than our previous maximum. So -5 is not greater than 0, so we will do nothing and we will increment I. I will become 1 and gain of I is 1 as well. Now we will sum it with our current altitude, so -5 plus 1 will give us -4. Now we will again compare our maximum altitude and the current altitude. -4 is not greater than 0, so we will keep max altitude as it is and we will increment our I pointer. I will become 2 and gain of I is 5 now. Now we will add this gain of I with our current altitude and it will give us 1. Now we will compare it again. Is 1 greater than 0? So yes, 1 is greater than 0, so we will update our max altitude as 1 and we will increment our I pointer. Now I becomes 3 and gain of I is 0. We will add 0 with 1 and it will give us 1. Now we will compare if current altitude is greater than max, but they both are same, so there is no need for updation, and we will increment I to 4, which is the last element, and 4th point is 7. Now we will add 7 with 1 and it will give us 8, and this will be our final comparison, and we can see that current altitude is greater than our maximum altitude, so we will update our previous maximum to 8. And we have completed our iteration. So this max altitude is our answer, so we will return it back. Hence our algorithm is working theoretically. Let's start coding it right away. Visit this problem from the link given in the description below and do try to solve it because it is very easy and very simple to understand. If not, I will make it simpler for you. Let's start reading the problem statement. There is a biker going on a road trip and the road trip has n+1 points. This +1 point indicates the starting position 0. They have mentioned it clearly here. And we will be provided an array of integer gain. And this gain will give us the difference between two adjacent points. and our aim is to return the highest altitude that is encountered throughout the journey. We will skip examples for this problem now. I have explained an example while we were formulating our algorithm. So let's directly jump to the constraints. So they have said that the gain input will be of size n and n will be 1 to 100. So there will be at least 1 point and there can be about 100 points that the biker will go through. Then the altitude can be ranging from -100 to 100. So we have read the problem statement completely and it is pretty much clear to me right now. If it is not clear to you, read it again, twice and thrice, as much as you need, because the more clarity you have on the problem statement, the more clearly you will approach towards the solution. So now let us code our algorithm. Initially, we will declare two integers, max altitude and current altitude. Both these altitude are 0 initially, so we will set it to 0. Then we will start a for loop from I equals to 0 and it will go up to gain dot size and we will increment our I. Now within this for loop, we will perform the accumulation by adding the current gain to our current altitude. Then we will update our max altitude if the current altitude is greater than the max altitude that we have calculated previously. So we will use the max function here and we will compare max altitude and the current altitude which we have calculated just now. If the current altitude is greater, it will be assigned to the max altitude. If the max altitude is greater, then it will stay as it is. So this for loop will check all the points given in the gain input. We have made a syntax error here, so let's fix it with the semicolon. And finally, our max altitude variable will contain the maximum point that the biker has reached during his journey. So we will return max altitude back and our coding is completed here. Let's run it to check it. Alright, so our algorithm is working great. Let's submit it on all the test cases. So we have completed our solution here. I hope you liked this algorithm. It was very short and sweet. I will link the solution in the description below, so you can visit the solution directly. And until we cross our paths again, I bid you farewell.